Do you want an A star in additional mathematics? Then don't just practice routine questions. Practice the questions that were designed to challenge the best students. These old either or problems are absolute gold mines, harder thinking, deeper concepts, and exactly the kind of problem solving that make the real exam feel easier. Today, I'm going to solve some of the hardest ones in this video. So this one is from Summer 9, Paper 1, and question 11 on that exam. I have purposely kept that or, so you can see that some of the questions back in the day had this or either written. So there was a choice in these last two questions. And you can pause the video, copy it, and try it yourself. And then you can check my work. I'll solve them one by one, each part. A particle moves in a straight line such that t seconds after passing through a fixed point O, its velocity v is given by, so the velocity's expression is v equals to k cos 4t, where k is a positive constant. So this is a kinematics question. Find part 1. The value of t when the particle is first instantaneously at rest. So at instantaneous rest, this means that velocity is 0. So when you put your velocity expression k cos 4t equals to 0, you divide both sides with a k since it's a positive constant, and you will be left with cos 4t equals to 0. So 4t is now cosine inverse of a 0. So 4t will be a pi by 2. And there are many other values, but they are saying first instantaneously at rest. And remember, these are time values. So you need the smallest positive value. So from here, I can get t equals to pi over 8 seconds, right? And that should be the answer for part 1. Part 2, an expression for the acceleration of the particle t second after passing through O. We need an expression for acceleration. So we differentiate the velocity. So this will be k, a negative 4 sine of 4t. So you might be thinking, what just happened? If you haven't revised differentiation in a while, so when you differentiate uh, a trigonometric function with a composite angle, so you multiply with the derivative of the angle, which is the chain rule, and this will be now written as minus 4k, a sine of 4t, and that's it. Given that the acceleration of the particle is 12 when t equals to 3 pi over 8, part 3, find the value of k. So we know that the acceleration is 12 when t equals to 3 pi over 8, so we will just substitute the value in the previous part. So in place of a, I put 12, and in place of t, I put a negative 4k and a sine 4 times a 3 pi over 8. This will become 4 twice, and this is a negative 4k, a sine 3 pi over a 2. So you can either use your calculator to get this value, or if you know this value, this is 270, and sine gives a negative 1 on a 270, or a 3 pi over 2. So we get a 4k and 12. So k will be a 3. Using your value for k, part 4, sketch the velocity time graph for the particle for 0 to pi. So velocity's expression was given as k cos 4t in the start of the question. And in the previous part, we found the value of k as 3. So now velocity can be written as 3 cos 4t. And I want to sketch it from 0 to pi. So things to keep in mind is that there is a transformation going on. The amplitude is 3 and the frequency factor is 4, or you can say that the period change factor. So 4t, put it equal to 2 pi since this is a radian measure. So t is going to be a pi over a 2. So that is the period for this velocity function. So let's put an axis over here and try to sketch it. So pi over 2 is one oscillation and pi is the second oscillation. You can put your 3 and a -3 like this. And if you want to be a bit more clear, so you find it difficult to sketch, these 3 lines, let me just make it a bit better, like this and this and this. So this will help me sketch one cycle more accurately like this. And from here, it goes all the way like this. Remember, it's a sketch. It should not be like very accurate, as accurate as you can make. But the examiner is, in these kind of questions, they're checking like they're looking whether a student knows the amplitude. Does he know how many oscillations are there in 0 to 2 pi? So let's make the second cycle. Let's hope I make it good with my emulator. Okay, so this and this. Yeah, that should do. And part 5, find the displacement of the particle from O when t equals to pi over 24. So in order to get displacement, we will have to integrate the velocity function, which is 3 cos 4t and dt. And the limits of integration are going to be 0 to pi over a 24. So let's do that. So 3, we don't need to do anything with 3. Sine's derivative is cos 4t. So cos integration is going to be sine 4t. But do not forget that you need to divide it by the derivative of the angle. And that is how you integrate these kind of trig functions, 0 to pi over 24. These are the limits of integration. Let's apply those. So 3/4, I usually pull out this 3/4. I mean, the limits do not apply on the coefficients and constants, right? So this is going to be sine. 4 times the pi over 24 is going to be pi over a 6, and subtract the sine 0. The lower limit. So 3/4 sine pi over 6, sine 30 is a 1/2. So my answer is going to be 3 over 8. And since it's displacement, this will be in meters. And this one is taken from Winter 11, paper 1-1, question 10. And I would like you to pause the video, copy the question, try it yourself, and then later you can check your answers. The figure shows a sector ABC of a circle center C. We can see there's a center and a sector given. Radius 2r centimeter, where angle ACP is 3 theta radians. So we can see there's a 3 theta, but it's kind of divided into 3 identical smaller sectors as well. Let's see. The points D, E, and F and G lie on an arc of a circle center C. Okay, so these D, E, F, G, this is another sector inside a bigger sector, and its center is C and radius R. The points D and G are the midpoints of CA and CB. So D and G are the midpoints. So that's why the radius is exactly divided in the middle, like CG and GB. They're same. So you see, like, there's something worth noting here as well. I am not ignoring any detail of the question. So make sure you read the statement carefully so you don't miss out on anything, right? Okay, so where was I? Angles DCE and FCG are each theta radians. I can see that in the diagram. The area of the shaded region is 5 centimeters squared. So we know that the area of the shaded region is 5 centimeters squared. Part 1. By first expressing theta in terms of r, show that the perimeter p centimeter of the shaded region is given by this. So how do we express theta in terms of r? There is a condition which is given. Area of the shaded region is 5 centimeters squared. So let's apply that idea. So how do we get the area of the shaded region? So this is going to be the bigger sector. Like, what's the strategy here? The bigger sector, I can see. If I find its area and I subtract these two white sectors, which are identical, I'll get my shaded area, right? So you can say that half and r squared, which is going to be 2r squared. And for the bigger sector, the angle is going to be 3 theta. So the idea I'm using here is half r squared theta, which is the radian formula for the area of the sector. Subtract double of the two unshaded sectors, half r squared and theta, right? Since its angle is just a theta, and put it equal to 5. So let's see, what do we get? It's going to be 4 times 3. So 12 r theta divide 2. And I can get rid of these and minus, oh, sorry, my bad. This should be r squared, right? R squared theta equals to 5. So this is again 6. So 5 r squared theta equals to 5. So I need theta in terms of r. Let's divide both sides with the 5. So the 5 goes away. So theta is going to be 1 divide r squared. Let's box it, right? So first I needed theta in terms of r. So this is what I've got. And now I need to find the perimeter. Now simply see how many arcs do you see and how many straight edges do you see. So I can see this is R, and these two are given as well. Okay, so now 3 of the edges are arc lengths. So I need this major arc, AB, which is a bigger one. I need DE and FG, and obviously this whole arc as well, right? Okay, so let's do that. So simply I can put a 4R for the perimeter, right? And I can see that this is there in the expression. So what about the arc lengths? I need the bigger arc. Arc AB is going to be, so what's the formula for the radian arc length? That is r times theta, the radius times the angle. So I'm putting a 2r times a 3 theta. This is the bigger r, right? Now add the smaller arcs, which are obviously identical, so I can do double of r theta, right? Let's simplify this. What do we get? 4r is going to be plus 6r theta and 2r theta. So this is going to be 8r theta. So now I can prove it here. So perimeter now will look like 4r plus 8r times 1 divide r squared. I'm using the expression that I already calculated earlier. So hence 4r plus 8 over r is going to be the expression for the perimeter, since one of the r cancels the other one. And that is what I was trying to prove. Part 2. Given that r can vary, show that the stationary value of p can be written in the form k root 2, where k is a constant to be found. So this is a calculus differentiation question. We proved the perimeter's expression was 4r plus 8 divide r, but rewrite it like this. Differentiate dp over dr. This is going to be 4 and minus 8 are a negative 2. And in order to find the stationary value, you set your first derivative equal to 0. This will give me 4 equals to 8 over r squared, and r squared will be 2, and r is a root 2. So now I need the stationary value of p. So put this r value back in the expression. So this will give me 4 root 2 plus 8 over a root 2. So you can either, I mean, this is better if you rationalize this bit. So this is going to be 8 root 2. I'm just doing it. You can either use your calculator to get this, but let's see. 4 root 2 plus this is going to be a 4 root 2. You can check this. And hence, I'll get 8 root 2. So this is indeed the form k root 2. So k should be 8, right? Okay. So case found, part 3. Determine the nature of this stationary value and find the value of theta for which it occurs. So in order to find the nature, you redifferentiate, you find the double derivative, and you need to differentiate this thing again. This will be 0 minus 8, a negative 2r, a negative 3. So let's write it as 16 over r cubed. If you sub your r value, if r equals to root 2, then d squared b over dr squared is going to be 16 over a root 2 cube, 16 over a 2 root 2. So that's 8 over a root 2. But still, my purpose is met. I can see this as a positive value, hence the nature is minimum. So this is what they mean by justifying or determine, right? So how do we get the theta value? We already figured out in earlier part that theta is a 1 divide r squared. So if you sub in r equals to root 2, this will give you theta equals to 1 over 2. So this is the theta value at which it occurs. And this one is from Winter 11, paper 1-2, question 11. Again, I would encourage you all to copy it, save it, try it on your own, and later you can check my work. A curve has equation this y equals to ln x squared minus 1 over x squared minus 1. So natural log function in the numerator and algebraic function in the denominator. The domain is more than 1. Part 1. Show that dy over dx is this expression where k is a constant to be found. So this requires the use of quotient theorem. Differentiation. Let's begin. So dy over dx. Second, the denominator as it is. Differentiate the numerator. Okay, let me just write the full steps. Otherwise, I would have just done this straight away. Minus, and now you need to keep natural log of x squared minus 1 as it is, and derivative of x squared minus 1. Divide the whole thing by, this is going to be x squared minus 1 whole squared. Okay, so I can write it like this, right? Okay, so let's begin. X squared minus 1. Here I will get 1 over x squared minus 1 times a 2x. Okay, that's how you differentiate a natural log function, x squared minus 1. And this is going to be just a 2x. Divide the whole thing by x squared minus 1 whole squared. All we need to do is just simplify the numerator since the denominator matches the result which is given. So this will cancel out with this expression. In the numerator, you will be left with, let's write it over here, 2x minus 2x natural log of x squared minus 1. Divide the whole thing by x squared minus 1 whole squared. And finally, I can write my answer, factor out the 2x. This is going to be 1 minus natural log of x squared minus 1 and divide it by x squared minus 1 whole squared. So this is my expression. And they were saying that k is a constant to be found. So k is going to be 2. Part 2. Hence find the approximate change in y when x changes from root 5 to root 5 plus p, where p is small. So now we need to remember the small change approximation or the equation. So this goes like delta y over delta x is approximately dy over dx. So what is the initial value? Let's get delta x. The final value is a root 5. take out the initial value. So you'll be left with a p, right? So now we find dy over dx at x equals to a root 5, the initial value. Okay, this is where the change begins. So this is going to look like 2 root 5 and 1 minus natural log of a root 5 squared is a 5 minus 1, and divide the whole thing by a 5 minus 1 whole squared. This will give me 2 root 5, 1 minus natural log of, this is going to be 4, divide the whole thing by 4 squared, which is a 16. So I don't need an exact value for this one. I can use my calculator to get this value. So let's get it. 2 root 5 bracket. Let's keep it outside. 1 minus, so what's that? That's natural log of 4. So this is ln 4, bracket close. Let's put a fraction over 16. So I'm getting a negative 0.10797. Negative 0.10797. So approximately correct to 3 sig figure, I can write it negative 0.108. So this is going to be negative 0.108, and delta x, if you multiply, this will look like p, and that is the approximate change in y. Part 3, find in terms of e, the coordinates of the stationary point on the curve. So I wanted my expression for the derivative and the equation of the curve as well to get these coordinates. And another thing is when they say in terms of E, it's just like asking exact answers. Okay, so what do we do? First, we put the first derivative equal 0. So if a fraction is 0, only the numerator is 0. And remember, k is 2. So 2x and 1 minus natural log of x squared minus 1, and that it equals to 0. 2x equals to 0 is not applicable. Remember, since x is more than 1 in the start of the question, it's given. And so the only answer possible will be from this part of this factor, right? So natural log of x squared minus 1 equal to 1. E equals to x squared minus 1, change into the exponential form. So x squared is going to be e plus 1 or 1 plus e. So x is going to be, now this turns out to be plus minus e plus 1. But remember, negative e plus 1 root is not applicable again since the domain is more than 1. I mean, sometimes you see that in the mark schemes, the rejection isn't mentioned. But I want my students, my followers to do like a better mathematical expression. Always give reason why are you rejecting a specific solution. So, okay, so x is going to be e plus 1, and you can say only, right? So now I need the y coordinate for this. I need to use the first part, the equation of the curve. So y is going to be natural log of e plus 1 minus 1. Reason? You get it like root of e plus 1 square. Okay, and divided by e plus 1 minus 1, right? So this cancels, this cancels. In the numerator, I've got natural log of e. In the denominator, I have e. Do you know what is natural log of e? It's 1, right? So y is going to be 1 over e. So finally, you can give your answer as root e plus 1 and 1 over e. So these are the coordinates of the stationary point on the curve. And this one is from Winter 12, paper 1-3, question 11 again. You can pause the video, try it on your own, and you can check my work later. The tangent to the curve y equals to 5e to the power x plus 3e to the power negative x at the point where x is a natural log of 3 over 5 meets the x-axis at the point q. Part 1, find the coordinates of P. So in order to construct the equation of tangent, you need to first differentiate the given curve. dy over dx, this is going to be 5ex, since the derivative of the exponential function. If its power is just x, is ex plus, this is going to be 3, a negative e negative x. So let's simplify this, 5ex minus 3e to the power negative x. And now, in order to find the gradient of the tangent, you need to substitute the x value given. So x is going to be natural log of 3 over 5. So let's plug this in. So you can say sub, and this will give you dy over dx will be now 5e to the power natural log of 3 over 5 and minus 3e to the power a negative natural log of 3 over 5. Now, this is a very important trick you can learn. I mean, it's a rule as well. E to the power natural log of any function is just that function. You can check this, try this with different values. So let's apply that idea. So this is just going to be 5 and 3 over a 5. Even if you sub it in your calculator, you'll get the same value. And here, I can do one more thing if I want to apply the same idea. I can do 3 over 5 raised to the power negative 1. And now if I apply this, okay, I could have canceled this, but I just left this. Okay, so this is going to be 3 over 5 to the power negative 1. I can write it 5 over 3. So this cancels, and I'm left with a negative 2. And this is the gradient of the tangent line. Okay, so I've got the x coordinate, but I need the y coordinate as well to find the equation. So I can use the same idea. Let's sub the x coordinate, natural log of 3 over 5, inside this equation of the curve. So 5, I can do this quickly this time, ln 3 over 5 plus 3 e to the power a negative ln a 3 over 5. And if I apply the same idea, this is going to be 5, 3 over 5 plus 3. And this is going to be a 5 over a 3. So this will turn out to be 8. So the gradient is negative 2, and the coordinate is natural log of 3 over 5 and 8. So let's find the equation of the tangent, which will be y minus y1 equals to mx minus x1. Now my target is not to simplify the equation of the tangent. All I need is the coordinates of P. And what is P? This tangent line meets the x-axis at the point P. So you can say on x-axis, y is 0. So let's sub this in the given equation of tangent in the point slope form. This will be minus 2, x minus natural log of 3 over 5. And I can get a 4 if I divide both sides with a 2. So 4, and this is going to be x minus a natural log of 3 over a 5. So now I'm running out of space. X is going to look like 4 plus natural log of 3 over a 5. Nowhere does it say that you need exact coordinates, but let's give the answer as exact. When they don't mention, you can give your answer anyway. You can either give it as a decimal number. So I'm getting 4 plus natural log of 3 over 5 and comma 0. So these are the coordinates of the point P. The area of the region enclosed by the curve, the y-axis, the positive x-axis, and the line x equals a is 12 square units. Now, understanding what does it look like, you've got some curve, I mean, whatever way that is, y-axis, x-axis, and the line x equals to a. I'm just making this up. So the limits of integration for this will be 0 to a, since they are saying the area. So I know it has to be a definite integration question. So I'll put an integral 0 to a and 5 e to the power x plus 3 e to the power negative x. Integrate this and put it equal to 12. By doing that, I need to show that this ends up this equation. So 5 integral of e to the power x is just e to the power x, but this is going to be e to the power negative x divide a minus 1, right? So put the limits of integration. You can avoid this step, straight away write a -3, but I just wanted to show you the complete thing. 5ex minus 3, and let's write it e to the power x. So I want to apply my limits now. I can see there were no negative index in the result I'm trying to get. So that's why I made my e to the power -x positive by switching from numerator to denominator. So I'll get 5e to the power a minus 3 over e to the power a, upper limit, minus the lower limit, 5e to the power 0 minus 3 over e to the power 0 equals to 12. This will be 5e to the power of a minus 3 over e to the power of a. This is just going to be a negative, 5 minus a 3, so minus 2, and put it equal to 12. So now I can write it like 5ea minus 3 over ea equals to, let's say, 14. So now multiply the whole equation by e to the power a, and I will get 5e 2a minus 3 equals to 14 e to the power a. Rearrange it, and this will give you the desired result. Now we solve part 3. So we showed the result already in the part 2. So the same equation needs to be solved. So this is 5e to the power 2a minus 14 e to the power a minus 3 equals to 0. So this is a quadratic in e to the power a. So you can use substitution to solve equations like these as well. So let u be e to the power a. So this equation will now look like 5u squared minus 14u and minus 3 equals to 0. So I can middle term break this equation, plus u minus 3 equals 0. And you know what to do, 5u, u minus 3, plus 1, a u minus 3. And this will be u minus 3 and a 5u plus 1 equals 0. So I'm getting two answers for u. One is a positive 3, the other is a negative 1 over a 5. So switch back, since u was just a dummy variable we supposed to solve this equation. So e to the power a is going to be 3, and e to the power a is going to be a negative 1 over 5. This will not be possible, as you know that exponentials are never negative. And another reason is if you apply logarithm on this equation, this will turn out to be an undefined equation. So here I can say, if I apply natural log, this is going to be, a will be a natural log of 3, and that is the value of a. And this one is from Winter 11, paper 1-1, question 11. Try it on your own, and later you can confirm your answers. The figure shows a sector OAB of a circle, center O, radius 10 centimeter. Angle AOB is 2 theta radians, where theta is within 0 and pi over 2. A circle, center C. There's a circle inside. Radius R touches the arc AB at the point T. So we can see it touches the arc. The lines OA and OB are tangents to the circle at the points E and F, respectively. So you see, I'm not missing out on any detail. So always make sure you read the statements carefully. Part 1. Write down in terms of R the length of OC. So this is OC. And we know that this is R, since it's the radius. And this complete thing is 10. I'll show you why this is 10, because this is a sector center O. So all of the radii are going to be same, all of the radii, right? So if that is 10, then this is 10, and all of them is equal to 10, right? So you can say OD is 10 centimeter, and CD is R centimeter. This implies that OC is going to look like 10 minus R. That's a 1 mark part. part 2. Hence show that r is this. So now we need the radius in terms of theta. There is a property of tangent and circle or any curve. Tangent touches the circle at one point and radius is perpendicular to tangent. So this is r and this is a 10 minus r. So now we need to write r in terms of theta, right? So let's give it a go. Since it involves a sine theta, so I'm going to use sine theta equals to, I'm solving part 2 over here. Sine theta equals to r divided 10 minus r. You might be thinking, why did I go with sine theta? So always keep an eye on what you're trying to prove. So now the trick is to make r the subject. So let's go. 10 sine theta minus r sine theta equals to r. Let's add sine r sine theta to both sides. So this will become plus r sine theta. And here I can factor out the r. This will look like 1 plus sine theta. And this is a 10 sine theta. This way, r will now be 10 sine theta divided by 1 plus a sine theta. And there we go. It's shown. Part 3. Given that theta can vary, find dr over d theta. Derivative of r with respect to theta when r is 10 divide 3. So let's differentiate dr over d theta, the result we got earlier. 1 plus sine theta, I'm using quotient rule. And 10 sine theta's derivative is going to be 10 cos theta. Minus sine, 10 sine theta as it is. And now we differentiate the denominator, and the derivative is going to be cos theta. And divide the whole thing by 1 plus sine theta whole squared. Now, the problem here is that my derivative is in terms of theta, but I'm given an r value. So now we need to find the theta value when r is a 10 divide 3. So for this, I again use the same result. So let's do it over here. So I'm going to put 10 over 3 equal to 10 sine theta over 1 plus sine theta. So get rid of the tens, you divide both sides, and this will look like 1 plus sine theta equals to 3 sine theta. So I'm getting 1 equals to 2 sine theta. And now sine theta is going to be a 1/2. Now you might be thinking I can get this value uh, using a calculator, but I just want to show you a non-calculator trick as well. So if this is the scenario, we know that this is 1 and this is 2. So you can complete the triangle by using Pythagoras theorem. So 2 squared minus 1 squared root is going to be root 3. So this will look like root 3. So now whenever I have sine theta, obviously I use a 1/2, but for cos theta, I can use a root 3 divide 2. This is one way of using exact answers, but otherwise we know that theta is just a pi over 6 if you don't use this triangle. So I just wanted to share a non calculator trick to solve these kind of questions. Okay, so let's put them. So I know that this is going to be just a 1/2, and this is going to be 10 root 3 divide 2 minus a 10 times a 1/2 and times root 3 over 2 over 1 plus a half squared. So let's get this. This is going to be 3 over 2 and a 5 root 3 minus this will be a 5 root 3 over 2. Divide the whole thing with the 3 over 2 squared. So I can just get its value using calculator. I was just sharing like what can be done if you stuck somewhere on a non-calculator question. I hope you don't get these kind of difficult questions in your paper 1, but you never know with advanced mathematics, you often end up somewhere like this. Okay, so divide 2, and I'm using my calculator, and let's get the numerator first and put a fraction. So that's a 5 root 3 divided by, a, you can say a 9 over a 4, right? So let's see, what do we get? I'm getting 20 root 3 divide 9. So this is 20 root 3 divide a 9. Or you can, if you want to give a 3 significant answer, you can just write 3.849, which is a 3.85. Part 4. Given that r is increasing at 2 centimeter per second, so d r over dt, the rate of change of radius is given 2. Find the rate at which theta is increasing when theta is a pi over 6. So we need d theta over dt. That is what we are looking for. So this can be a confusing part. So you might be thinking that we found the derivative earlier, but we used an r value. But you see, when I switched, you can rewind and take a look at the solution. So theta's value was turning out to be pi over 6. So this is the same expression. Like if you use theta is equal to pi over 6, your answer is going to be the same as the previous part. So just the wording is a bit twisted. So let's use chain rule. So d theta over dt will be d theta divide dr times the dr over dt. There are a lot of ways you can write it, but this is usually I teach my students. This is the chain in the chain rule. So you've got dr over d theta. If they say this thing, you can just switch your answer, the previous answer, since that was a 20 root 3 divide 9, I flipped it upside down, into 2. And this is going to be 9 over 10 root 3, or maybe you can give a decimal answer for this as well. I mean, nowhere does it say the exact value. So let's give both. So this can be one possible answer as well, and the other is going to be, let's write 9 over a 10 root 3. Just check. Yeah, that's it. So this is going to be 3 root 3 divide 10, or 0.520. 3 root 3 divide 10, or 0.520. And this one is the last question on my slide. This is from Summer 12, paper 1-2, and question 11. Copy it, try it on your own, and later you can confirm. The position vectors of points A and B relative to an origin O are A and B. So position vectors mean that it's tied to O. O is a starting point. So you can just write it somewhere. OA is A. I can't bold it each time, so I put an arrow on top. OB is going to be a B, right? So you can also put it like this if you want to. You can use your diagram, just put these A's and B's. Next, the point P is such that OP is a 5/4 of OP. So look at these, like these O and B and P. Since there's some ratio holding them together, this is a collinear relation. Collinear means that they lie on the same straight line. The point Q is such that AQ is a 1/3 of AB. So AQ is a 1/3, so QB is going to be a 2/3, and you get the idea. This is also a collinear relationship. Remember, find the difference between the collinear and the parallel. Both have the same condition, but the collinear relationship shares a common vertex. So you can see that A is a common vertex. So you know that these vectors are starting from the same point. They lie on the same straight line. The point R lies on OA such that RQP is a straight line. So RQP is also a straight line, where OR is a lambda OA. We don't know what is that ratio factor. And QR, on the other hand, is a mu BR. Okay, so some relations are given. Let's take a look at this. How do we solve this? Part 1. Express OQ and PQ in terms of A and B. So now we need these missing links, OQ. In order to find OQ, it's better, just think it this way. I need to find this OQ. If I can find AB, that will be really useful. So let's go. How do we get AB? You can use either OB minus OA if you know how to deal with position vectors, or right now, if you're just looking at your diagram, in order to reach from A to B, you can go A to O and O to B. So that's a negative A plus B, or you can write a B minus A just using the diagram. This is not the answer. Now, AQ can be written as a 1/3 of B minus A. And I'll use my AQ to get the answer for OQ. So OQ is going to be OA plus AQ. So let's write it A plus a 1/3 B. Let's expand it, minus a 1/3 A. So this is going to be a 2/3 A plus a 1/3 B. You can also write like this, or maybe you can factor out. I'm just writing it. You can write it this way as well, like a 1/3 of 2A plus B. Whichever way you want to give your answer, both are completely acceptable answers. There's another thing, I need PQ as well. So in order to get PQ, when you get stuck somewhere, you can always check the ratios. So OP is given and now OQ is given. So let's how do we find OP? So it's a 5/4 of OB. Let me just solve this over here. So OP can be written as a 5/4 of OB. OB is a B. I need this vector, and I've got OQ already. I found it earlier in my part. So let's use them to get PQ. How do we do that? Head to tail or tip to tail rule. So in order to reach from P to Q, I can go P to O and O to Q. So when you switch vertices, OP, the negative is going to be a PO. So minus a 5/4 B plus OQ. So I'm using the same answer, earlier answer, 2/3 A plus a 1/3 B. So don't worry, you can use calculator as well. So in order to write them in terms of just A and B, simplifying, minus 5/4 plus 1/3. So minus 5/4 plus 1/3. I can save time on a calculator paper by doing this. So this is going to be a negative 11/12 B. I have kept my previous answers right here and the information because I'll be needing those to solve part two. In part two, it says express QR in terms of lambda, A, and B. So let's take a look at QR. So I can use, since it says lambda, check which expression has lambda. So OR's value is a lambda A. Let's write it lambda A for this one, this vector, right? Not the full OA. So I've got OQ, which is right there. I can use it to get QR. So QR can be written as QO plus OR. So QO is a negative 2/3 a negative 1/3 B, since I'm changing the direction. So in vectors, when you change direction, the signs become opposite. This is known as a negative of a vector, plus lambda times A. Now, this is a part which I want you to be careful about. There's a nice way you can write this expression in terms of A and B only. So factor out the A, then you can write it like lambda minus a 2/3. So the A goes out, it's factored, minus a 1/3 B. And that should be the answer for part two. Part three. This time we need QR in terms of mu A and B. So you might get confused that we already got QR, but now we again are looking for the same vector, but this time it is in terms of mu A and B. So this is a bit tricky part which can confuse students. How do we get that separate path? So we know that QR is a mu times PR. So now how do we get this PR? If we try to use this path like PO and OR, this one, so you will end up using a lambda again, which we do not need. We need this expression only in terms of mu, A, and B. So we use a trick. We write PR as PQ plus QR. So we have the value of PQ. I've kept it right over here. Let's open this up and free write it like this is going to be mu times a PQ plus a mu times a QR. And then in the next step, you can subtract mu times QR, and this can be written as 1 minus a mu. And mu times, this is a 2/3 A and minus 11 over 12 B. So now QR can be written as mu over 1 minus mu times 2/3 A minus 11 over 12 B, which looks a bit weird, but this is the answer for this part. Part 4, hence find the value of lambda and of mu. So this part can be done using the answers for QR. So I've got QR in terms of lambda and mu. All we need to do is now compare the coefficients of A and B, form systematic equations, and solve them. So let's simplify this QR in terms of mu. This will be a 2 mu over 3 times 1 minus mu A and minus 11 mu over a 1 minus mu and a 12 over here and B. So you can pause the video, do these calculations yourself. It looks a bit weird, but that's how it is. So since QR is the same vector, so equate coefficients of A and B. So first equation can be lambda minus a 2/3 equals to 2 mu over a 3 times a 1 minus a mu. So the second equation is going to be a minus 1 over 3 equal to a minus 11 mu over 12 times a 1 minus a mu. So this looks like an easy equation. I can just solve this one to get the value of mu and then get lambda. So 3, 4 times, if you time both sides with the 4. So negative cancels the negative. So 4 times a 1 minus mu is going to be 11 mu. 4 minus a 4 mu will be 11 mu. So 4 equals to 15 mu, and mu's value I'm getting is 4 divide 15. Let's use it to get the value of lambda. So now lambda minus the 2/3 is going to be, I mean, you can use these values in the calculator. That's fine. I can use a 4 over a 15 since this is a calculator paper, and 3 times a 1 minus a 4 divide 15. Okay, so I'm making my calculations simpler. This is a 8 over a 33. So now lambda is going to be, just add a 2/3. And this is a 10 divide 11. And these are the answers for part 4. And if you have reached this far, believe me, you are very well on your path for A star. So if you found this content useful, make sure you comment, like, share, subscribe. And remember, keep visiting for more useful resources. This is Global Math Mentor, over and out.